Hello. Hi, Brian.
Hi, sir.
Hi, Bruno.
Hello, Itai.
Good morning, good afternoon.
Hello. Hi,
Hello.
Rob.
Hello.
Hi, Gilberto. Okay, so hello, everyone. Good to see you.
Hello.
So today also we have the guys from Fraunhofer. Do you want to introduce yourself? Sania?
Hello, am I
Hello?
audible to everyone?
Hello? So welcome to the meetings.
Yeah, hello.
Do you want to introduce yourself?
Hello, am I audible to everyone?
Yes, yes.
Yeah, okay. Hi, everyone. I'm Sneha Kadam. I work at Fraunhofer IS Dresden in Germany. And I've been working on the file layer of bunch of wires for the past almost 2 years. And yeah, I thought I could join this meeting to know more about like said in the description about the interoperability, because right now we are working on that. We are trying to figure it out. So yeah,
Mhm.
just for some information. Thank you.
Okay, great.
Hi, myself Lavakuma Navlipuri. I'm also from Fraunhofer on the same team as Sneha. So I generally work on the layouts of the interfaces and the ESD problems which we face in the chiplets.
Okay. Um,
Thank you.
one subject. Yeah, sorry. So one subject I wanted to discuss. I know I checked last week and I saw that the UCIe license is actually for not for commercial usage. So they allow you to download the UCIe spec, but it says it's not for commercial usage. So I didn't get a clear response from the OCE organization, from Cliff, but I think that we won't be able to use reference to the UCIe, because once we use it, it means that people are not allowed, will not be able to do a commercial modules with our standards.
Yeah, but I think we just need to. They just need to get some kind of agreement in place with UCIe. I mean,
Okay.
UCIe has done that with other, Like they do it with, they have an agreement with MIPI for debug.
Mm-hmm.
And MIPI
Okay.
is not, I think that's pretty open. I don't know what its licensing scheme is, but if there is any, you know what I mean? And I know they've done it with other groups. Like I know UCIE has one with DMTF, which is definitely an open standards.
Mm-hmm.
So there's precedent there. I think we can do it. We just probably need somebody on OCP side to actually, you know, that has the authority to actually get it going.
I see.
So my thought anyways.
But if you're a commercial company, just a regular company, can you use the UCIE? You can't use the UCIE. You need to become a UCIE member, right?
I don't know, because if you just go buy IP from an IP vendor that's UCIE, do you have to be a UCIE vendor? A UCIE member?
I don't think so.
Yeah, so I
Mm.
guess that's the way I think of this too, is that we're treating it as a piece of IP, but
Mm-hmm.
I'm not the expert, right? So I don't know.
Yeah. Okay. So I didn't get any message from Cliff. So okay. So you think it's not it might be that it is okay. There is a chance
I
it's
think
okay.
there's complementary, and we could
Mhm.
craft a good message to UCIE about it, and then make sure we understand where the dividing line is. But
Mhm.
so maybe we can't publish the PHY information or specific, what every bit does and everything, but the concepts I
Mhm.
would hope we can reuse, because I mean they're not something super proprietary there that I could think of. But
Okay.
anyways, we'll see where it goes, but hopefully we could do that.
Okay. I see. So anyone did any progress with defining the API that we discussed last week? Anyone to present?
I have done a little bit.
Mhm.
I have almost
Okay.
restart from scratch my thoughts, and I
Okay.
am happy to present my line of thought. I
Great.
hope it's good enough for having a conversation,
Yes.
not enough for having a solution yet. So I'm happy to share my screen. Give me 1 second.
Yeah, and I also did work on we talked about having a data model for how chiplets would interconnect and
Yes.
properties. So I did some work on that I can show.
Okay. Great. So Gilberto and then Rob.
Okay, so let me get started. There are too many things in this screen, so let me guide you through what I am thinking. I hope I am sharing the right screen. So you see a PowerPoint screen here, right? Do you see like an open compute project screen and it's like chiplet on top and so on and so forth?
Yes.
Okay, great. So on the top left is my initial line of thought. Okay, and Rob is not necessarily your example of chiplet, but I was trying to see how to start organizing things. So the line of thought here is we have a system in packet that is looks like the top left, where there will be a host. And I am assuming there is a CPU host master chiplet, and there are 2 slave chiplets. Okay, and then in terms of performance analysis, the host master will need to gather information from this chiplet and will need to have some control. And then this host master, we have this system on packet, might still need to communicate to the external world. And I am extracting this from the way I understand things work in data centers. Okay, you have a host machine, you might have multiple nodes, each node is collecting information. In this case, I am thinking there is a PCI card from coming out as a system in packet, and then you have the 2 slaves and the master here. So you need to monitor activity, congestion, compute and bandwidth from this chiplet, okay? And you might need to control things like frequency, voltage, workload allocation, memory arbitration, priorities, and frequently throttling. So this is the top right. This is the kind of thing that you will need to arbitrate, and hence you will need registers to capture this kind of information and be able to deliver quality of service in your system in package. Then in terms of where to get started, in terms of not trying to reinvent the wheel, what I am thinking is get some inspiration from in this case, RISC-V has some specifications of performance registers as a CPU and how this connect to Linux execution, things like performance, the perf tool. There is some kind of recommendations of standard extensions in RISC-V for how this works. There is also some definitions of board management control, typically in these nodes in a data center. And I understand that PCI also defines some level of interface and communication, so PCI RAS. So I am planning, or what I am thinking is trying to extract how these things work. And then with that in mind, think, okay, we need a set of registers that will work in these slaves, some firmware connected to, in this case, I am assuming a RISC-V, but it could be x86 or ARM architecture, then the tools and the performance. Okay, so this is kind of what I'm thinking now. Beyond that, before I hand over for comments, I started an Excel because I thought it was easier. I was getting stuck with working on Word. Okay, beyond that, okay, what do we need? So we need cross-chiplet monitoring. So we might need system level performance monitors, interconnect monitors, and memory access profilers. We need tools and integration, so performance, trace tools, telemetry. And then we need to assess things like utilization and bandwidth, access to core utilization, access to bandwidth utilization. And from here, I am starting to gather, okay, what this might look like. Okay, some of these tools I am Googling and being honest, also using ChatGPT to get some inspiration. So I am in the early phase of exploring what these things mean. And then I was trying to look also how this might look, or what are the kind of registers that we might need. And this is more a template and an initial stamp of, okay, what are the kind of registers, how we organize them, and so on and so forth. So at the moment, I'm still in a research phase, trying to go deeper of what is out there. I also was trying to extract some information of the kind of register for performance available on RISC-V to get some inspiration. And that's kind of where I am at the moment. Okay, I have the Word document I was working some months ago, but I wanted to start fresh with some high level and thinking, is this the right approach? So if I go back now to the PowerPoint, this is kind of the summary of what I am trying to achieve. So I'll pause there and ask for feedback. And you guys let me know if this makes any sense to you or what do you think.
Yeah, it looks good. I mean, you might also want to look at the ARM.
Yes,
I think it's very
yes.
similar to the RISC-V stuff, but they obviously have a long history of some of this kind of stuff, so it might be interesting to see if there's any ideas there.
Yeah, I agree. And I don't know, I am guessing that AMD in terms of x86 also has registers.
Yeah, but we don't have any, we're not gonna have anything that's public, or not much that's public.
Okay, okay.
I mean, I
okay.
can see if I can find some, but ARM, I know everything is public, right? You can just go to their website and grab everything, so it might be a better place to start. We probably have bits and pieces in places, but I don't know if we have anything that's as comprehensive, documented as what ARM has.
Okay, yeah, no, I was planning to look at ARM. I didn't want to exclude x86. So
I don't think it meant, yeah, for these purposes, I don't think it's a big deal. I mean, everybody's going to have to come up. You're going to try to create a framework and an infrastructure, and if people want to play in this, they have to come up with, they have to adapt it, right? And even the stuff we do internally it may be structured differently than ARM, but the concepts are all the same, right? I mean, performance counters are sort of fundamental to everything, right?
And one question, Rob, if I was thinking here, I didn't explain this. So I was thinking like having like an equivalent of a BMC inside the slate chiplet, basically as a concept. okay, that is gathering kind of the information of the chiplet, storing it, and then you can DMA it into the master or something like that. I am assuming that UCIe doesn't specify anything like this, and because I think there is something, but I'm not sure how much it is. I haven't looked in detail.
Yeah, there is this idea of a debug test and debug framework. It really is about having a separate network and discovery. It doesn't really tell you what to capture or how to move it. So there's an infrastructure in there about, connecting and discovering, but that's about it. So anything you do is probably can be built on top of that.
But when you're talking about the BMC equivalent, are you talking about the interface with BMC or the entity in charge of communicating with the BMC?
Yeah, so it's not the interface, it's more the functionality as an abstraction level.
Okay,
And I know close to nothing of this, okay, other that I know that the BNC basically is a kind of device that can gather information from other devices, and then the host can access data from that. So I am thinking that as a concept, we need that, we can use that concept inside the chiplet, and then the interconnect, I was thinking maybe is you just transmit it as a UCIe, and then it's a memory map area that you can DMA the information, extract it or something like that.
Okay. So because I was thinking that in ARM kind of typical architecture, they have dedicated microcontrollers for the system control and the manageability control. So the manageability controller is named MCP, manageability control processor, and then in a chiplet architecture, you can have one MCP per chiplet, reporting to, I would say, a central MCP in charge of the communication with the BMC. That's one option. And then
Okay,
you need
no, that's very good, and it's aligned to what Rob is saying. So I guess what I will try to do next week is dig down a bit more into the ARM rather than RISC-V. That's probably a better approach. And then I will evolve with this idea a little bit. That makes sense.
And you actually define the performance of the bandwidth of the interface of the BOW, or when you say the registers that with the counters, what performance of what section will they have?
So at this moment, what I am thinking, and this is because it's easier for me, I am assuming that this chiplet might have might be a set of accelerators in a cluster working with an internal NOC. Okay, so imagine that this is like chiplet as accelerators. There might be multiple instances interconnected with an NOC across them. So I want to extract information of how they are behaving in the context of the system in packets. So I will start getting performance of, are they utilized, these accelerators? Are they idle? Are they being blocked because they don't have enough memory? Because there is congestion? So it's trying to gather that activity. There are other things I haven't put here yet that they will be potentially also we need to extract things like power consumption and temperature as well that have been added to this here as well, because it's not directly related to performance, but I was thinking that we might need through these registers to get information about the temperature of the chiplet and the power consumption too.
Okay.
The power and temperature are in a different chapter.
But by the way, I work on this topic. I did some homework,
Yes.
so
On the power and temperature?
yeah. So I
Yeah,
put yeah. I don't know if you're done, Rodrigo.
yes.
Gilberto,
So okay,
are you done?
yeah, Gilberto.
Yeah, no.
So power and temperature, we set it to a different subject.
Okay, fair enough.
Which
So I don't need to worry.
Bruno
But there
will work
are
on.
also links with performance, because
Okay.
performance measurement, it's also a way to assess power consumption when you do not have the when you're not able to monitor the, I would say, the voltage and the current.
Okay.
Maybe I can if you're okay, I can just share one slide I've got
Yeah,
more slides,
please.
but I would need to submit it internally before sharing.
Okay.
Yeah, absolutely. From a point of view, any idea you have, it will. But that's what I thought. Even if there is a separate chapter, there will be some implications in terms of performance and power and how you
It seems
optimize
that
for it.
I cannot share if you are still sharing.
Okay, sorry.
Yeah.
One thing, Gilberto, on what you presented. So from you had the firmware. So we just need to define I think the APIs of the functions, and we need to be agnostic to the CPU, right?
So in terms of that, that's one question I had, and I wasn't sure. I tried. That's fine by me. We can discuss that more in detail. I wasn't sure even when you think about an API. That API in the diagram I had, that API is to be run probably in the host. So
yes.
So I was trying to think in
no,
that firmware.
Or in the also in the slave. There is should be a corresponding. It might be that there is a corresponding API.
But then you're assuming that's the bit that I wasn't sure how to split, to be honest. If we need to force that there is if you have an API in the slave chiplet that I saw, you might not need a CPU OS running there. So you just have a bunch of registers. So there is no real API in the slave. The API will be in the host requesting the information and how that information is being requested. As a first stand.
Okay, I understand. Okay. Yeah, you're right. I agree. You're right, because we are not obligating that you'll have a CPU in some kind of chiplets. Like in IO chiplet, we are not obligating. So yes, it's not always you'll have an API in the slave. You're right.
So at the moment, I am trying to put even if we don't go in detail, try to put the picture. Let me evolve a little bit with the feedback in the next 2 weeks, and then we can get back to exactly what we need in terms of detail.
Okay.
Okay. Can you see my screen?
Yes.
Yes.
Okay, so maybe we can start with that. So I've got a set of slides, but it's not. It's kind of work in progress. And so maybe I will start with the figure on the right. So basically, if you want to handle both power and thermal, you need, I think, at first to have some knowledge about the system itself, meaning the number of chiplets and also the way the chiplets are arranged and the characteristic of each chiplets. So I will not give maybe an exhaustive list of the parameters, and maybe it will be the next things to discuss. So it can be the maximum junction temperature that can be reached by a chiplet, the maximum power consumption that can be for a sustained workload. So you can see it as a TDP per chiplet. It can be the number of power rails that you can control independently. So you can control it can be the on-off control or the voltage level. And for thermal aspect, we may also integrate the thermal coupling information. So meaning the effect that one chiplet can have on another chiplet on the you have the self-heating effect of one chiplet when a chiplet is having some activity, some processing, he can heat himself, but a chiplet can also it can also get warmer due to another chiplet activity. Right? Any question or comment so far?
So just to clarification, Bruno. So the way you're describing this, you're not just thinking of getting the thermal information of one chiplet. You're trying to analyze the effect of the thermal and power of one chiplet in the other chiplet.
Yes. Yeah.
Okay. And
So
what you're describing here is extracting the information from each of the chiplet, and then based on the information from all of them, you can then go back and control what you want to do.
yeah, so basically you need two kind of information, information per chiplet, but also some kind of information of the whole system.
Yeah, makes sense.
So basically we can, I don't know if it is the right term, but we need some kind of discovery to get this information. And then based on, and I also did not mention, but one also characteristic of the chiplets is the supported operating states. So an operating state can be, as an example, a DVFS state. So meaning that when you start the system, you need to have a starting point, a starting operating mode for the different chiplets. And so you can start with that. And so you can then apply this control, these operating states, and I would say the regular or the nominal I would say configuration of the chiplets. And then during runtime, you will get on a regular basis telemetry information. And so in the telemetry, you can have for the thermal aspect, you can have the average temperature and also the hottest temperature for the hotspot of a chiplet. And for the power, you can provide, if it is available, the voltage level, the current, the power consumption. And so maybe we have to figure out a way to provide this information if we do not have the required sensors for that, because it's not always possible to sense both the voltage and the current. And this is where counters can be used somehow to assess the power consumption.
So
And
Bruno,
yeah.
sorry.
Mm-hmm.
So I think that so first, I think that next step is actually defining the structures, the descriptors that you just mentioned.
Yeah.
With
So I
all
started to do that, in fact. Yeah.
Yes, right.
So as an example here, it's I would say the properties that we want to get from the system and the chiplets. And the different parameters. Not yet an exhaustive list, and I need to consolidate it. And I also started to do the same for the telemetry. And so telemetry, is it here? Basically the average temperature, the hotspot temperature, and then the current voltage, power, and eventually the power limit if we think it can make sense. That's basically the applied power limit, but the applied power limit is somehow it's already an input for the chiplets. And what I did not mention is that you can use this information to take decision and then to send controls to the chiplets. And you can also take into account events. And so it can be a thermal trip event. It can be
so you say that you mean that the telemetry is like a regular messages, but if you have like a emergency issue, then you send it through an event like an interrupt.
If I remember well, I think that Rob, you identified this kind of messages, right, in your architecture?
Yeah, there's definitely that. I mean, UCIe already, they have a couple defined, but there's a framework for these kinds of things, which I think is what you would build on, right? It's these out of band low latency events that require some immediate action to save, could be to save the chip from melting, right? It could be a security event. There could be lots of things, but in the concept of this, yes, thermal is always needs these out of band low latency events, I think.
Okay, so that the telemetry is here, and then I think I listed the events here, so we can send an event saying that the power limit is reached. Before sending an event related to a thermal trip, because here when there's a thermal trip, there is a risk of runaway, thermal runaway. Before that, you can have the what is maybe equivalent to the proc hot, a typical pin on a CPU chip. It's a pin saying that there is a limited thermal headroom, that and it can be used for doing a kind of thermal migration, or it can be used to request a thermal migration. So thermal migration meaning that at system level you need to see if you need to modify the way to operate the chip, maybe to transfer a part of the workload on another chiplet or things like that.
Okay.
Okay, and then maybe finally about the software layer. So I indicated the management, the API for the management at this level, but then we may want to distinguish this level to other software layers related to the hardware abstraction layer and the policy layers. So policy layers, maybe we can provide examples, but I'm not sure that we need to specify something. So you may have static policies with fixed priorities or dynamic policies based on workload and things like that.
Okay. So you're saying the policy will be part of the unique implementation of the chiplet, but it will be based on the API that you defined.
Yes, so it can use the it can be compatible with this API. Yeah.
Okay.
Bruno, I got a question. I don't know
Mhm.
if I know very little about this, but in data center systems, I understand there is also, I don't know if a standard of APIs or pseudo standards of how the different nodes are gathering information, and I think you can use a Slurm or something like that at system level to understand the overall rack or data center system to collect information and then control it. Is your description aligned with that at all? Have you used some ideas from that, or I am trying to understand if there is a commonality in terms of framework of what happens in a rack system, or if you know?
Yes, maybe it could be interesting as to do the comparison. And as an example for the events, you, on this, I would say that these two signals can be compared to discrete signals that you can have at the chip level. So usually on a CPU chip, you have a term trip output and a proc hot output. And basically proc hot, it is used to indicate to the BMC that you have troubles to regulate the temperature. Okay, so you're asking for support from the BMC. But in that case, there is no need to communicate with the BMC because you need to communicate with a central entity in charge of handling this issue. Okay, that's only when you consider that there is temperature issue at the chip level that you cannot handle. In that case, you need to report it to the BMC. And
Yes,
then,
sorry, carry on.
And then the thermal trip, you also have usually a dedicated pin for that on a CPU, and basically it's I would say a housekeeping function used to avoid to burn the chip, and it is usually used to shut down the power supply. So we can do this. Yeah.
It sounds, I mean, this is great. I mean, I like the idea and principle of making this hierarchical. So this approach of BMC is great because we can now extrapolate this to the lower layers, like in an architecture
but
level.
it's
So I like it.
definitely interesting to compare the mechanisms and at system level and at chip level. Yeah.
Okay.
Okay.
So yes, looks good.
Okay.
Great. So Rob, you want now to present?
Sure, I can show you what I've
Mhm.
find it here. So what I did was I got started trying to think about how to describe a SIP out of chiplets and what you would need. And then I wrote a bunch of stuff up and then I put it into AI and it spit out an entire gigantic document. But I won't go through that. It was just thought it'd be interesting for folks to see that. But the idea that I wanted was that we needed to be able to describe how chiplets connect. And so this kind of builds on the compatibility stuff, but also is more about what's the physical and logical connectivity through there, where the management paths are, how are resets and powers connected, these kinds of things at the architectural level, not at the I know there's other work being done at the physical layer of which layers and have to go on and which signals and things like that. So I looked at it, I thought, okay, IP exact kind of already has a lot of these capabilities in it, right? They have this idea of connection and describing pieces that are connected. So it seemed like a good place to build on, at least for the data structure kind of standpoint. And then the other thing is, so IP exact is there, it's human readable. There are various tools to visualize it. And then the idea would be to, can we capture all the chiplets and their physical and logical connections between there, but do it in a way that it should be expandable. So yeah, so I gave it some prompts, and it just went to town and created lots of stuff that I hadn't thought about before.
That was the instruction to the
Well,
AI.
some of it there was some back and forth discussion between myself and the AI.
Okay.
to refine it a little bit, but in the end, it did a pretty good job, because these coming up with these the parameters, and these are all things make sure there's no conflicts in parameter names and things like that. It's pretty.
You did not identify any hallucination?
I don't know, because I haven't vetted this entire document yet, so I can't say that for sure. But it helped me like really talk about. I mean, it helped me think about things that I didn't really think about, like like these physical characteristics. Like, okay, well, you need physical XY and bump pitch and things like that. But then it had things like is the die rotated? Which sides are all the things on? There's a bunch of UCIe based things. There's lane reversal. There's a lot of stuff in there, because I had given it like the UCIe spec and said, help me find the types of information I would need to do that. So it was pretty good from that standpoint. So I need to go through this and vet it a little bit more to make sure, but I guess the main concept I wanted folks to see was the use of IP exact. And actually, let me share what one might look like.
Yeah, so IP exact, it's also a well-known method to package IPs.
Yeah, so that's the other thing, is we're just basically now moving from IP to chiplets, but it's you need a lot of the same types of information. Okay, so let's see. Can people see this? Oh, this is not the one. Is this the one I want to show? I can get it. Why is it not? Oh, weird. It's not showing my. There we go. Okay. Can you kill that?
Can you zoom in? Zoom in a little
Yeah,
bit?
let me see. I have no idea why I've got this weird thing going on, but well, all right, now I gotta figure out how to zoom in. Zoom in. I was doing control. Oh, it's control equal. Weird. All right. Not I don't use VS Code all that much, so
Yeah, but it is great to for different formats. It's great.
Yeah, it's a great tool. I'm starting to use it more for other stuff. It's just the display stuff I did. So in this case, this is all IP exact, right? There's a bunch of information about what's up front. You know, this is all based on XML, which is very verbose, but it also means that, you know, it doesn't leave a lot for a lot of mistakes. It's easy to find this. So in this case, there's, you know, we go through, we define what the chiplets are, you know, the information about them. So in this case, I had 4 chiplets. So I'll show you a picture of it in a second. So there's a CPU
Rob,
and I, go ahead. Yeah.
Rob, but I think it's great, but in addition, we need to also translate it to like a structure that can be saved on chip on its memory.
Right. So that's what's nice about IP exact is now it's an XML format. We could turn it into anything we wanted.
Okay.
Right. We could turn this into a data structure. You could turn it into a binary in some way, right? So,
but you need at some point to get the number of bits for each parameter, or is it defined here somewhere?
No, but we could. I guess that's the thing is we can figure out how to do that. There's lots of ways of turning XMLs into binary that exist. So, you know, and I'm hoping there might already be something that we can use. I haven't spent a lot of time looking for it.
Okay.
But what I was concentrating on more was, you know, what will we need to describe? And then I think we can crunch this down into something that can fit on chip. Or something that could at least be in Flash that you could read parts of if you needed it.
Do we really need this in on chip? Because I think a lot of the parameters we're talking about here really just kind of go into firmware. So you might be able to just compile your firmware against the IP.
That's the thing is that you may need some of it, you may not. You may not need all this information for everything. So you could, I guess that's why I was looking at IP exact, because you can go through and pull out what you need for various what you want. So if you want to visualize this, you need a lot more information. If you already have a runtime, there's probably a bunch of stuff that you don't really care about. Like you probably don't care about vendor IDs and device IDs because already in the chip, there's nothing you can do about it.
And you were mentioning physical information here too. The firmware doesn't really care.
Yeah, exactly. So that's kind of what I was thinking about, like I said, IP exact, which is we can put everything in there and then we can pull out the pieces we need. So I don't know if that answers your question, Atai, as well, but I think we can crunch this down and you could just say, hey, you know, for this thing, like for firmware, I only need these types of fields with this kind of information. Does that make sense?
Okay. So we need to mark which fields should be on chip in a memory, and I think you won't be able to. You can't avoid defining for each field. Again, maybe the AI can do it, but I think that there is another column that needed, which is the number of bits for each parameter.
Yeah, I think what we need to go through is figure out and I think some of this will be driven by as we go down the API work. What information do we really need? The APIs would need for runtime.
Okay.
That's kind of what I was doing, but this is kind of a catch-all right now for everything. Because you can see, like I said, I defined the chiplets, then I defined, you know, the logical links between the chiplets, And I didn't, again, I used AI to help me generate all this because there's no way I could have typed this all in the time.
And it all based on the UCIe?
No, well, this one was basically saying, hey, this example I had used all UCIe, but really you go in and you say, when I have a logical link, there's interconnect technology, and if I had the XSD up here, you could see that it's validated against a UCIe, bunch of wires, SERDES. I just listed a bunch of types of technology, right? So, and then if you use UCIe, you would have to go in and say, there's some information that would probably be you need to know about that UCIe that could be carried in here. And this is all UCIe terminology about states and retrain and things like that.
Yeah. So we need also for the so it's a specific UCIe, but we also need for the bunch of wire and for the controller.
Exactly. Yeah. So whatever this is really not designing it. It's really just reflecting what's in the design. So whatever information we think we need that needs to be carried on, and to be able to visualize what a sock is, or to see how things go or how things are connected, that's the kind of information we need.
And Rob, do you think that we need to expose all the UCIe parameters? I'm just wondering if there is no parameters.
Yeah. So the question is this, would we want this to cover all the stuff that Atai was working on for his compatibility?
I was wondering if there is already a kind of parameters exchange during the initialization of the link, because I think that's
there is some, but some of this is based on my knowledge that UCIe is coming up with a lower power profile one that has static, that doesn't do parameter exchange, because it's simpler. So I mean, there might be a bunch of stuff that we don't want in here. Like I said, I used AI to help me do this, and it was like super verbose about everything. But I guess I wanted to make sure we had the concepts down of logical links, and then there's what the physical connections are, how they're all connected. I even had stuff in here because I said, what about flow control between chips? And because if you have AXI, you may need protocols and flow control buffers and things just to see what it would look like put in here. So there's some of that. What else was I going to show you? Oh, there's also, in addition to these logical paths, I also was like, here's the reset information. And then clocking, and then this idea of, just keeping power. This power stuff could be really expanded if we needed it to be, like all the things we've just been talking about. So anyways, I guess what I was saying is I was playing around with it just to see what it would look like. It seems to fit together. What I also wanted to show was, because I have access to really cool AI vibe coding tools, I can share you what this looks like, because I just asked Klein to build me a graphical viewer of the chip of what to take that AIP exact and build me an HTML version of it. So this is kind of what I was thinking. In the end, these would be tools people could build or go across, which you could go in and you could see what the SoC would look like before you build it, what the parameters are on all the links and things like that. So
in this, it looks great. So in this example, it's like the Nexus, it's the Nexus system chip. So it describes the different chiplets. here?
Yeah, so each of these is a different chiplet, right? So if I click
Mhm.
on it, you can see these are all the stuff. This is all the information just pulled from the IP exact.
Okay.
So so here's an AI, here's a CPU chiplet. It's got size and the information. This is all the information I had put in the chip.
In the IP exact of the chip.
Yeah, the IP exact
Oh.
of the chip, and this was just a visualizer of that IP exact information.
Okay.
I just wanted to see how it would hang together. And so you can see like here, I've got, you click on the thing, the point of this was not to show off the tool. The point is it's a lot easier to see what those parameters look like when you can
Yes.
visually see it as opposed to trying to parse IP exact in your head.
Mhm.
Yeah, so there's that, and then there's the management links between the chiplets as well, so we could have more information about that. But it seems to kind of hang together to give us some sort of structure. That's what I really want the feedback for, is we think this IP exact method is a good way to go, and then we can really start diving into what should be in the IP exact and what should not be in the IP exact.
So you think that instead of maintaining an Excel with all the parameters, we should maintain the IP exact? That's the
Well, I guess that's the question as to what
Hmm.
level we want to do that, right? So I'm not sure that we should figure out if it makes sense to put the compatibility stuff in here, because compatibility is really just between two chiplets,
Mhm.
right? The only two you're going
Yes.
to connect. So do I need all of that information for every chiplet in the system? I don't know. I mean, there might be a lot of information in one place that you don't really need in one place, if that makes sense.
You're saying that for compatibility, we don't. So this is a different tool, not for compatibility, but for actual.
What is your
Uh,
SIP constructed with that the information we would get out of there could be used by the APIs to go off and know, right? So if your main SIP controller is in this Nexus IO hub, it has to know how it can talk to all the other chiplets. Then it would have to
Yes.
know what it has on those chiplets. So does it have
Mhm.
performance counters? Where are they? Does it have the power control stuff that Bruno is showing, like how to set it up, what information can it get back? So all that could be in one place. So I was thinking about more from the firmware standpoint.
Okay.
We could expand it to be compatibility, but it could get really big
I see.
and unwieldy. So we should discuss how we wanted that to look.
And so this configuration, which the IO hub is in the middle, which is so it is defined in the also in the the IP exact file.
Yeah. So
Can
I
you
mean, this like I said, this is built in AI. There's no middle. It just decided to. It has
not middle, but yeah, what we in a
yeah. But
not
what I
middle,
did
but
was I
this is the
said,
control. Yeah.
yeah, what I did was I said this is the main management.
Main management. Okay.
Right. So I actually used UCIe terms. I think I call it the management director. And then I said it's got management links directly to each one of these.
Mhm.
To each of the other chiplets. So I haven't played around with it. We could, in theory, we could show these networks going all over the place, and they don't necessarily have to follow the functional network. But but yeah,
that's
the
good.
idea was
It's a
you define that,
clear.
and go ahead. Yeah.
Yeah, it's a very clear image. It's good. So just
Well,
wanted
that's
to
what I
know
was
that.
saying. It's like it was hard for me to, as I was working on the IP exact to keep it, and I was like, oh, I have AI tools. I can just tell it to parse the IP exact and give me some HTML representation for it, and it did a pretty good job, I have to say.
Yeah.
I was
Yeah,
impressed.
So the information. So what I wanted to ask, if all this information for doing this diagram is inside the IP exact file. You didn't have.
Yes. Yeah, that's all it used as an input was the IP exact.
Okay.
The information. So that's kind of what's nice about if we go IP exact for this kind of information, it's all self-contained. So you only need one file. and then you could take that file and transform it into whatever you need. Like in this case, it transformed it into, you know, pictures for HTML, but it could also transform it into data structures for an API.
Yes.
Then
So I
it
think
could,
that the next step is important to see how it converts to a data structure that can be saved on the chip.
Yeah, I'll have to do some more research to find out what the best way to do that and how to tag the various parameters, you know, for export, what should be exported and what shouldn't be. So I have to do some research to see the best way to do that.
and then Rob, it means
Okay.
that the XML should be hierarchical at the end, right?
Yeah, yeah, that was kind of the point that I had, which was, you know, it's it should be a hierarchical, and you could put even more stuff in there, right? If you have IP, if you wanted your IP specific information that's inside each chiplet, it could be in there as well. It's just you may or may not necessarily need that depending on your output, right? But what's nice about IP exact is that it has that idea of hierarchical and, you know, connectivity and everything already. So
Yes. You have a different file for each of these chiplets, or it's a one file which with several definitions?
I have right now I have one file for everything, but you could put them all in separate files. And that's kind of what I was thinking, is that you'd have a, you know, somebody would have a chiplet and they would have an IP exact file for their chiplet. And then you would include that when you're building up your SOC, and, you know, putting the connectivity and everything together. So now then you'd have multiple XMLs, but they'd be hierarchical, and you could then extract the information needed.
Okay. But by the way, once you build this tool, is it possible to share it?
Sure. Yeah, I put it on GitHub somewhere. I don't think there's anything proprietary in here, but yeah. Does OCP have their own GitHub somewhere? I can just throw it on GitHub.
No. Maybe you can put it in our Google Drive.
There is a OCP GitHub, but I don't know. It seems to be somewhat deprecated from the stuff being put on Drive. But for something that's code like this, it might be more appropriate to resurrect that.
Yeah, if Brian, if you know, if not, I can just throw it up on GitHub somewhere. But if we have an OCP space, then I'd be more happy to put it there as well.
Yeah, hold on a second. Let me see if I can find it real quick. I mean, we used to use it for the transaction link layer spec.
Okay.
Where are you storing the system document?
That's on Drive.
Well, could you just put it in that same location? Or?
Yeah, I can. It's nicer if it was GitHub, right? Because then you could do pull requests or whatever. And if I do updates, I could put them someplace as opposed to just copying it. But whatever works for folks. Yeah.
Yeah, it's just opengithub.com/opencompute-project. But there's and there's a whole bunch of projects linked off of there. So I don't know how that's administered or anything like that.
Oh, okay. Okay.
Well, like I said, our transaction link layer is linked off of there, and we used to keep documents there, but we kind of just stopped using it when we changed editors.
Oh, okay. Okay. Anyways, I'll post what I have, and then I'll figure out where to put the code so you guys can see it.
Okay.
But I'm sorry, I need to drop. I have to get to another meeting.
Yes. Oh, okay. It's 9 o'clock already.
Yeah.
Okay.
So
okay. Thanks everyone. We'll
Thank
continue
you.
next week.
Thank you.
Okay.
Thank you. Bye.
Bye.
Thanks.
Bye. Thanks.